we're going to go ahead and get started here. So we have the sample question that they put up for the 2020 exam, and this one has us dealing with genetically modified and regular corn. So if we look here, we have 33 plots of land divided into 2 half plots. One half plot was randomly selected to be planted with GM corn. The other half plot was planted with regular corn. And we've got tables below showing the information about the yields in bushels per acre of these various plots. So, looking here, the first question asks us to explain why the yields from one type of corn are not independent of the yields from the other type of corn. So normally, when we are looking at independent-dependent, we're thinking in terms of probability, and this one twists it a little bit. We are looking at this one instead in terms of experimental design. So with this, we're looking at factors in the experimental design that are going to lead to this, rather than doing probability calculations. So here, we are looking at various factors in the fields. So let me go ahead and type and think here. So because there are differences in the characteristics of the plots, there will be differences in the yield of corn between plots. These plot-to-plot differences will affect both the GM and the regular corn, causing these to be associated rather than independent. All right, part B is going to be taking a look at the summary statistics here. So looking at part B, says, based on the summary statistics, would it be more likely to obtain a yield of 123 or more bushels per acre from a plot of GM corn or a plot of regular corn? So if we look at this one is actually a little bit of a trap, and this one is a time trap. This is the shorter question, so we have 15 minutes to do this one, plus 5 minutes to submit. So you could calculate z-scores and do all of that, but that is going to be not as helpful. Instead, we want to think about how distributions behave, so we're going to look at the means and standard deviations here, and we see that the mean for the GM corn is 125 and change, and the mean for the regular corn is just above 120. So we would say, because the mean yield for GM corn is above 123, and the mean yield for regular corn is below 123, it would be more likely to have a yield of 123 or more bushels per acre from the plots of GM corn, or from a plot of GM corn. This is asking us to extend this to plots in general and make predictions. So we are going away from just the sample and making descriptions of the overall yield there. Moving ahead to part C, it shows us a box plot of the differences in the yield, and we need to describe the distribution. I recommend, while you're doing the exam, anytime you see something like this, give yourself a framework to work in. It is easy to, as you go through, forget something and leave a part off that you otherwise would have put on. So shape center spread is what we're looking at with regards to distributions here. So the shape of this one, it is skewed right with an outlier at about 20. So the distribution is skewed right with an outlier at about 20 bushels per acre. The center looks like the median is about 3 bushels per acre. And the spread. There are a couple of things that we can do for the spread. We can look at the IQR. We can look at the range itself. I'm going to go ahead and use the interquartile range for this distribution. And it appears to be, so it goes from, looks like about 6 to about -1. So it looks like it's about 7 bushels per acre, that spread there. I'll pause for a sec for questions in the chat and to get the next piece up. All right. So for the next part, I ignore the cursor that got stuck there. Students conducting a test of these two hypotheses, that the difference is 0 for our null hypothesis, and for the alternative that the mean of the difference is not 0, where mu sub d is the population mean difference, GM minus regular in yield, in bushels per acre, for plots similar to those used in the study. The conditions for inference have been met. One of the conditions for inference that was met is that the sample size of the differences is greater than 30. Explain why it is necessary to satisfy this condition. So this gets back to us needing it to be approximately normal. So here I'm going to say in order to conduct inference, the sampling distribution must be approximately normal. The sampling distribution of the means must be approximately normal. Because the sample is skewed right and has a fairly extreme outlier, we need a large sample size in order to satisfy the central limit theorem and render the sampling distribution approximately normal. There we have it. The last part here is asking us to interpret. So if we go here, the test resulted in a p-value of 0.0003. Based on the p-value, what conclusions should the students make? So this p-value is very small. This means that it is highly unlikely that we would have taken a sample with okay, fine. Let's try this again. That we would have taken a sample with x bar sub d as large or larger than the one we encountered, assuming the null hypothesis is true. Because it is unlikely, we can reject the null hypothesis. There is statistically significant evidence that the mean yield of GM and regular corn is different. Going to pause for just a sec to see what questions or concerns you all have, and if there's anything else in particular that you all would like to go over. So if there's anything, go ahead and drop that in the chat. All right. Well, for the last bit of our last review session, I'm going to employ something of an old reference, but if you can dodge a wrench, you can dodge a ball. And I am going to be throwing out a problem that is tougher than what we can expect on the AP exam, so we can see what to do with difficult and strange and unaccustomed problems. So I'm going to be taking a question 6 from an AP exam from a couple of years ago. So give me just a second to get that copied over there. So this question has us looking at an experiment in which 2 men and 2 women will be randomly assigned to either a treatment group or a control group in such a way that each group has 2 people. People are identified as man 1, man 2, woman 1, and woman 2. There's a table showing the different arrangements. And there are 2 methods that are going to be used here. So I'll give you folks a second to take a look at that, kind of let this all sink in. And then we're going to take a look and just kind of walk through this one. All right. So part 1 has us looking at the sequential coin flip method, and I am going to go ahead and crop this a little bit. Change my mind. Alright. So a fair coin is flipped until one group has 2 people. An outcome of tails assigns the person to the treatment group. An outcome of heads assigns the person to the control group. As soon as one group has 2 people, the remaining people are automatically assigned to the other group. So this is looking really at how the method of randomizing can affect things. So we're doing man 1, man 2, woman 1, woman 2. So for arrangement A, in order for this to occur, we need to have heads for, tails is the treatment group, so we need to have tails for the first 2 flips. So that would be a probability of 1 out of 4 here. So I'm going to go ahead and put in a text box that I can write in here. And fight with technology just a little bit. There we are. And nope, still not quite. There we are. Okay, so for that first one, we have a probability of 1/4 because we need to have those 2 flips go in the exact right way. For arrangement B, to get there, we need to have tails for man 1, heads for man 2, and tails for woman 1. So that's 1/2 times 1/2 times 1/2, or a probability of 1/8. For arrangement C, this is going to mean we need to have tails, heads, heads, tails. So that's 1/2 times 1/2 times 1/2 times 1/2, so that would be 1/16. For arrangement D, actually, I apologize. I was incorrect here on arrangement C. We're going to go back for a second. My apologies. So once we've filled up the control group, we are done there. So that should be 1/2 times 1/2 times 1/2. That should be 1/8 right there. That was my mistake. All right. Arrangement D. 1/2 for man 1, 1/2 for man 2, and the rest get filled in, so that's going to be 1/4. Then arrangement E, that's going to be 1/2 for man 1, 1/2 for man 2, 1/2 for woman 1, so that's a probability of 1/8. And last but not least, part F, 1/2 for man 1, 1/2 for man 2, 1/2 for woman 1, and woman 2 gets assigned there. Something good to check on is to make sure that your probability actually adds up to 1 when you've calculated it. So we're going to check here. So we've got 1/4 plus 1/8 plus 1/8. So that's 2/8, 3/8, 4/8, 5/6, 7/8, 8/8. So our probability is 1. So we've got the probabilities there. For the sequential coin flip method, what is the probability that man 1 and man 2 are assigned to the same group? So what I would do for this one is look at these arrangements. So that's going to be arrangement A has that. Arrangement D has that. So A and D. So that is 1/4 and 1/4. So that would be 1/2 there. For the probability that man 1 and man 2 are assigned to the same group. Moving on ahead. There is a chip method. Excuse me. So for the chip method, the two chips are marked treatment, and 2 chips are marked control. Each person selects 1 chip at random without replacement. Complete the table below by calculating the probability for each arrangement occurring if the chip method is used. So for this one, I am going to go ahead and copy the table of arrangements again so that we can see that and work with that. Just a moment. All right, and I'm going to put a reminder to myself. Our order here is man 1, man 2, woman 1, and woman 2. So if we're looking at those, the probability that man 1 is assigned here is 50%. When we get down here, man 2, the probability, there are 3 total chips left, and 1 of them is for the treatment group, so he has a probability of 1/3. So our overall probability there, sorry for the disorienting scroll, the probability for arrangement A, right there, is going to be 1/2 times 1/3, which would be 1/6. All right, arrangement B. Our probability for man 1 is going to be 1/2 as before. The probability for man 2 is going to be 2/3 because we've got 2 chips left for the control. So that's going to be 1/2 times 2/3 times 1/2. So for that one, we are going to have a probability of 1/6. For arrangement C, probability of this is 1/2. Probability of this is 2/3. Probability of this is 1/2. 1/2 times 2/3 times 1/2 is going to make 1/6. Arrangement D, probability of 1/2, probability of 1/3, so that makes an overall probability of 1/6. Arrangement E, got a probability of 1/2 here. That man 2 is assigned to the treatment, that is 2/3. And woman 1 being assigned here is 1/2. So again, 1/2 times 2/3 times 1/2 is going to make 1/6. And moving over to the last arrangement, 1/2 for man 1, 2/3 for man 2, and 1/2 for woman 1. So that's going to be another 1/6. So we want to double check here, make sure this adds up. So we got 1/6 for 6 different possibilities. So that does add up to be 1. That's kind of handy. All right, then we've got the further question. For this method, what is the probability that man 1 and man 2 are assigned to the same group? So if we look here, the 2 treatments in which that happens, it's treatment A and treatment D. So that is 2 of those 1/6 probabilities. So that would be 2/6 or 1/3 for that. All right. For the last one here, we've got question C. 16 participants consisting of 10 students and 6 teachers at an elementary school will be used for an experiment to determine lunch preference. As the participants enter the cafeteria for lunch, they will be randomly assigned to receive one of 2 lunches, so that 8 will receive a salad and 8 will receive a grilled cheese sandwich. The students will enter the cafeteria first, and the teachers will enter next. Which method, the sequential coin flip method or the chip method, should be used to assign treatments? Justify your choice. So here we are looking at what is going to be the best choice here. And what we're really looking for is that all treatment groups or all possible arrangements of groups are going to have the same probability. So we saw here that the chip method had the same probability for all of the possible arrangements, whereas the coin method did not. So we should use the chip method here because all arrangements have an equal probability. Also, based on our calculations in parts A and B, the coin method is more likely to group students with other students and teachers with other teachers. In order to maximize randomization and ensure a higher likelihood that each treatment group will contain both students and teachers. We should use the chip method. And I see we've got a question, what's the difference between part A and part B here? So in terms of method, for the coin flip method, everybody who walks in has a 50-50 chance of being assigned to either group, and we just stop randomizing after we fill up one of the groups. So that led, because of the order in which people were assigned to those groups, that led to it being more likely that the two men are placed together. In part B, where we're using chips, so they've got 4 chips and they're basically drawing those randomly, so they are going through each person and randomly assigning them a group. For that method, because of the way that those probabilities work out there, it winds up being, I'm trying to look for the exact word to describe this, it's equally likely that all of those possible arrangements will show up. So I hope that answers that question there. If there's further questions, please feel free to put them in the chat there. I do appreciate seeing those questions there, being able to address those things. So, like I said, this problem is more complicated and more strange than what you're probably going to see on the AP exam actually next week. Some other things to think about, because they're doing a 2-question exam, almost every question that they're going to be giving you are going to be covering multiple topics. So you're not going to get a probability question and an inference question. You're going to be getting a question that has multiple elements. It's probably going to ask you about experimental design. It's going to be asking you about inference. It's really going to be focused on the conditions for inference and the interpretation rather than the calculation. In theory, this exam can be done without a graphing calculator, so I don't anticipate, but I don't want to say for 100% certainty, I don't anticipate that you are going to be asked to calculate any of the p-values run the numbers for a t-test, but you are going to be asked to set it up, think about the setup, and make some determinations there. So looking back at the sample question that they had, notice that this one started with some experimental design. It looked at some this one is a normal distribution problem in disguise here. Z-score kind of thing. We've got some shape center spread. We've got some conditions for inference, and we've got some interpreting inference and hypothesis testing. So that's the kind of format that I would probably expect that we'll see there. I've scheduled this one to go until 2:45, and that leaves us with just 7 minutes left. Are there any last-minute things that you all would like to talk about right now? Got questions about? All right. Well, I think we will adjourn just a little bit early here. Thank you, folks, for signing on and taking the initiative here. Good luck with your exam next week. Anything that comes up, last-minute questions or worries that you have, please do feel free to contact me. I've got office hours Tuesday and Thursday. I believe your exam is on Friday. My advice is relax, have your notes and other things easily accessible and handy so you don't have to go flipping through stuff. Take some time to read the question, and yeah, I'm pulling for you. I'm rooting for you guys. All right, take care, folks.